Hi, again, my name is Eyal and I'm the VP and GM for Biometric Solution for Intel and RealSense. So I start the way I start every presentation with a problem statement. So basically, from my perspective, the problem statement is to enable a transparent, secure, and private biometric solution. Basically, the way I see it in the last decade, the transition is that your face will be your identity as opposed to all of these cards, basically replacing all of these. Way I see it is that throughout the last, I would say, 2 years, we see an explosion in adoption of the Face ID in all of the segments, basically starting from vending machines, doors, in airports, ATMs, basically everywhere. And now to the gist of the presentation. So I would say starting at 2019, there was an explosion in terms of the AI and the capabilities of face recognition to actually outperform a human brain in terms of identifying between two similar people. And I gave two examples. One is the label A Face in the Wild, where you see the breakthrough roughly around 2016. And the NIST, the National Institute of Testing, you can see that starting 2019, where the algorithm was starting to be better than the data set they had, so they started to add more and more data sets to bring the error up again and then get basically algorithms to try to beat it again and again. Mug shots, visa, border control, and so on. A little bit about myself and about the group. So we've been in the decade of face recognition for about a decade and transitioned to AI roughly 2016. We've developed state-of-the-art solutions for most of the individual components that construct the face recognition pipeline. And I think the two major things about AI in general, but face authentication in particular, is one, data, and I'll explain in a second the amount of data and the diversity that we've collected. And the second is a good researchers to be able to beat and shave the percentage of the errors. A little bit about the face processing pipeline. Basically, when someone says that they got a face recognition, basically it constructs of these components. The detection, face detection, basically detecting all the rectangles in the region of interest. Analysis of each face. Anti-spoofing, where actually most of the companies that I've seen don't have a real anti-spoofing. They have something that they call liveliness. And I'll explain in a couple of slides the difference between these. And obviously the face recognition itself and some comparison. Basically to be able to take a face and transform it into a 512 vector that is not reversible. So couple of words about data. So just in a matter of order of magnitude, so we have data sets that starts from 2+ million annotated faces, where we actually had people manually annotate the rectangle around the face, as well as more than 500,000 annotations of the face landmarks, all of these points that helps us later on do some of the analysis. On a face recognition, we have more than 1.5 million unique identities that we've collected across the globe. So we're working with vendors, basically in most of the countries, from the Far East all the way to North America. Plus, one thing that we have and most of the companies don't have is this synthetic data generator, where basically we are able to generate any sort of a face, both the geometry of the face as well as the texture map, to basically generate all the diversity, age, ethnicities, expressions that we want to make sure that our solution is resilient to changes. Last but not least, on top of all of this, one thing that we've learned throughout the 3 years of deploying of our technology out there in the wild is making sure that our solution is really robust for the outdoors or for any lighting condition or environmental settings. And I've been walking around and asking how well solutions today work in outdoors and stuff like that. And it's not always working as well as it should be if you want to make sure that you are installed in a mall in Dubai, for example, or in China in a building that is like 50 floors, or in complete dark if you want to do an intercom sort of solution, and so on. So this is something that can be a make or a break for a solution to really hit the market. I'm going to do quickly one click down on each one of the components that I've mentioned earlier on the face detection analysis. So again, face detection is basically the ability to detect face or faces in an image. It's really, really, really important to make sure that when you detect faces in all shapes, in all head orientations, in all what we call accessories. It can be COVID mask, it can be any of the sunglasses or anything that basically can distract a standard face detection algorithm. Couple of things about false detections. It's important in security solutions to make sure that when you detect a face, the rectangle is really around the face itself and not around portions of the face. And we've seen such errors everywhere, because if you are detecting only portion of the face, that means that your AI algorithm would get what we call garbage in, which will mean garbage out, which means the face recognition itself will not work well in these conditions. So we need to make sure that we work well in all the scales. The next thing is what we call face analysis. So we basically detect 2D and 3D landmarks in real-world coordinates, as well as the image coordinates. We also detect head orientation, be able to give you an X, Y, and Z coordinates of the face for customers that would like to get specifics. For example, on ATM, they want to make sure, on access control gate, that you look toward the camera, versus on intercom, they want to make sure that you can pass even if you don't look toward the camera. So these analyses are very important to them. On top of that, recently we started introducing additional features, like whether the person is wearing a COVID mask, whether he's wearing sunglasses, age groups, genders, whether the person is wearing a hoodie or a hat. Each one of these are things that are important for customers to make sure that they can adhere a specific policy. So it's not just to give another feature, it's features that are relevant for our customers for deployment. Sorry, went the other way. One last sentence about the what we call 3D 3D morphological model. It's basically a model that was trained out of 10,000 different high-resolution scanned faces in all ethnicities and all ages and gender, to make sure that we are able to generate any sort of geometry, as well as texture, as well as expression of any face in the world. And there's actually a nice tool that I don't have in this slide, but we can play around with the parameters and you can see that the shapes are changing. Very important to generate diversity for your training data. Now the face recognition itself, when someone or everyone here talks about face recognition, so a little bit on the technology. Face recognition is basically the ability to take the face and out of the face generate a 512 or 256 or 1024 vector that uniquely identifies your face in the world. Basically, this vector can differentiate between everyone. So it's not that simple to generate such a compressed vector that will identify you versus other people. And the gist of the algorithm is basically to be able to squeeze this 512 dimension sphere to make sure that still it detects you in all lighting conditions, all head orientations, everything, and still be farther away from another person's sphere, such that it will not be mistaken on the identification itself. some of the tests and the advantage that you see also throughout the years, each one of our submissions, we are now in the 11th submission of NIST. We are the top 10 in the world considering in this face recognition. And you see that every year, since you collect more data, you got new algorithm developed and introduced every year. So we are improving anywhere between 20 to 50% of our error rate, which is significant. Some examples and maybe intuitive of how face recognition works or how you determine basically eventually that this is the same person or not the same person. So basically, given all the benchmark that you have, you define a threshold, for example, 0.8. Anything goes below 0.8 in the similarity, you basically declare that it's not the same person. Anyone that is above that, you declare that it's the same person. And you need to make sure that you take care for all of the changes, all the differences with glasses, without glasses, different head orientation, different age. We support age difference of up to 20 years. So it works between your visa and your real face, between your passport, anything we can identify. And there are also tests in NIST that validates that. One important trick that we did in the last year is to really force the algorithm to identify between people that really looks the same. So make it harder on the algorithm on the training, tweak the parameters such that on the test, we will be able to give the difference between these people, even though many of the current public algorithms and some of the cloud-based APIs that people are used to use are mistaking on these images. We are better on that, and we are able to differentiate between these. Last comment about the recognition itself is very important to make sure that you keep fairness and ethical consideration to make sure that you got all ethnicities well introduced in your data set, training set, and test set, ages, genders, everything to make sure that there's no bias. Bias is something that can be easily detected if you know what to look for in a specific face recognition technology. So there are tests that test basically against a bias on your algorithm results. All right, actually that's the fun part, the anti-spoofing. So I keep calling that anti-spoofing and not presentation attack and not liveliness, because there's a huge difference. Basically, our solution, sorry about the noise, it's not fun. Our solution really tackles all sorts of spoofing attacks. Basically, any, and you can try, by the way, our booth is right here. You can try to hack it with anything. 3D mask, latex mask, anything basically should not be tackled, as you can see here, basically. We've been tested in a lab in Europe, in Spain, for a week. 5 people were not able to hack it even once, and the standard allows you a 7% to be hacked. We were not hacked even once. And how we do that magic? So basically, in a nutshell, we got the 2 sensors, okay, kind of you can call it a stereo or depth-based solution. So we are able to identify any geometry attack, anyone that tries to hack our system with not face geometry. It doesn't need to be a flat paper. You can try to curve the paper. You can try to, do holes and put your nose in or eyes. Or will not hack it because it doesn't have the face shape. On top of that, we got an IR LED that basically reflects on your skin tone, and by the reflection, another AI model is able to say whether it's a person or anything else. We got what we call a vision model that combines the 2 sensors, is able to do some differentiation between them and running 2 different AI models to be able to say whether it's what we call a non-realistic mask like the Shrek or all of these Halloween masks also are being taken care of this. So all in all, the anti-spoofing, the way I see anti-spoofing is we got 5 different AI models that are handled like locks, one after the other, and we got an end operation on them. So basically, only if you're able to hack all of that, then you are a real person. And we do it on a single frame. So versus the traditional that was trying to do some sort of a liveliness or pulse detection or stuff like that do sort of a video, they need a couple of frames. We do it on a single frame, hence we are able to return a solution within 200 milliseconds. Okay, we don't need to get too many frames. We do it on a single frame. We have some of our validation and researchers actually generating masks or buying, I would say, masks of themselves throughout the globe. Also something that is important, what we realized over the years, if you buy a mask in UK, there's someone in UK that generates very expensive masks, versus you buy it in the US, versus you buy it in Asia, different material, different behavior. I guarantee one of them will break other solutions. We bought from 10 different vendors across the world to make sure that it's not just the shape and the texture, but also the material itself differentiated. So we can make sure that nothing breaks that system. The other flip coin of basically the not be able to hack the system is to make sure that it will be easier for you to get into the system if you're a real person. You don't want to get spoof all the time, what we call false spoof. So you want to keep your TPR, your true positive, also above 97% to make sure that you are giving it a good user experience. So we've collected tons of data across the world, given different accessories, different lighting condition. One thing that you need to make sure when you think about geometry, so these type of things change a little bit the geometry of the face, either from the surrounding or beard, facial hair and stuff like that. We needed to make sure that we are resilient to these changes, as well as COVID mask and other stuff that we need to make sure that we are resilient to that, and our geometry can infer from that it's a real person. All right, couple of new, I would say, feature that we started introducing, especially when we work with gate companies. So one of the things is tailgating. Basically, once I verified that you are really you who's trying to get through the gate, I need to make sure nobody is tailgating you. So we have our person detection and person tracking to make sure, and some classifiers to make sure that no one is tailgating you and basically using your face to get into prohibited areas. One, I would say, high-level glance of our solution. So we got on the right-hand side our camera device, which is a very small camera device, but it's doing everything. Basically, it's got the face recognition, anti-spoofing. All my lecture is done in that specific module. Though we have an SDK that runs on a host connected via USB or UART to that device if needed, we also have some Docker option to be able to give to connect other IP TVs to our solution to make sure that if we go into an already a place that already has installed cameras and they just want our cameras in secure areas, we enable this Docker solution, basically actually this one, to be able to have it working with our solution as well as other solution, all in a one-stop shop. So they don't need to basically unhook all the already installed cameras and install ours. They can use whatever was installed, plus using our cameras to specific areas. One comment or one slide about our hardware itself, the uniqueness of the hardware. So as I mentioned, we got 2 sensors. We got an LED and a projector that gives us several wavelengths, so we'll be able to do mainly the anti-spoofing better. We got the SoC and a secure element, basically making sure that everything, all the data is well encrypted, 256 or even 512 in new products, and nothing basically leaves the device. So all the recognition, everything is done on the device, and no image leaves the device. That makes our solution super in terms of the privacy and in terms of the security level. And we've committing to 1 to 1 million false positive and over Here you can see the true positive is 99.76%. So I would say, all in all, starting the conversation, we believe, or I believe, that your face is your ID. You'll see that basically everything will transition from all the intermediate solutions to face, since you cannot forget your face as you can forget your badge. The face works in all lighting conditions as well, as opposed to fingerprint. Then in some conditions, it will not be as accurate as it is. And basically, it has more features than palm or fingerprint on any of the other alternatives. And given our on-device, on-prem solution, we are keeping it private and secure, such that it's easier to adopt. That's it. Thank you.